Hello everyone, welcome back to the channel. The role of artificial intelligence in the future of combat aircraft is a subject that is transforming the entire concept of aerial warfare. As technology races forward at an unprecedented pace, AI is no longer a supporting tool but a central component in both the design and operation of the most advanced fighter jets the world has ever seen. Every part of the aircraft, from its sleek outer surfaces to the hidden intelligence deep inside its systems, is being shaped by algorithms that can think, learn, and adapt faster than any human pilot. This revolution is redefining not just how air battles are fought, but also who or what will be in control of the skies. The exterior of future combat aircraft is no longer designed solely by engineers relying on wind tunnel tests and physical prototypes. AI-powered simulation platforms can now run millions of aerodynamic configurations in a fraction of the time, analyzing how every contour, angle, and material affects speed, lift, and stealth. This means that the outer shell of these jets will be shaped for maximum efficiency while minimizing radar cross-section. Advanced composite materials are selected through AI-led optimization processes that weigh factors like durability, heat resistance, and electromagnetic absorption. Even paint is no longer just paint. AI selects coatings that can shift infrared signatures or alter color depending on environmental conditions, enhancing camouflage both to the human eye and to detection systems. The result is an exterior that blends elegance, function, and invisibility in ways that were once thought impossible. Inside the cockpit, the transformation is even more dramatic. While earlier fighter jets had cluttered dashboards filled with analog gauges and switches, AI-driven aircraft interiors are minimalistic yet deeply intelligent. A single panoramic display or holographic projection can present all necessary flight and combat information, instantly reorganized depending on the pilot's focus or mission stage. Voice and gesture controls replace many manual inputs, allowing faster responses. An AI co-pilot continuously monitors the aircraft's systems, the pilot's health, and the tactical situation, ready to make split-second decisions if necessary. This means the human operator is free to concentrate on strategy rather than being overwhelmed by the sheer complexity of managing high-speed combat in a hostile environment. Performance in these AI-powered machines reaches a level that human reaction time alone could never achieve. Flight control systems guided by machine learning algorithms can manage micro-adjustments to control surfaces hundreds of times per second, keeping the aircraft stable even during extreme maneuvers. AI can calculate the perfect angle of attack for missile launches, anticipate enemy movements, and plot the most fuel-efficient and tactically advantageous flight paths in real time. In coordinated missions, AI allows multiple aircraft and drones to operate as a single unit, sharing sensor data and coordinating attacks with machine precision. This networking capability creates a force multiplier effect, where each individual asset becomes more effective by being part of a larger, instantly responsive system. Safety is a domain where AI's benefits cannot be overstated. Modern combat is unpredictable, and even the most experienced pilots can be caught off guard. AI systems can detect structural weaknesses, overheating components, or hydraulic pressure drops before they become critical failures. They can adjust course and altitude automatically to avoid dangerous weather or enemy fire. If the pilot becomes incapacitated, AI can take full control, complete the mission, or guide the aircraft back to base for a safe landing. Advanced countermeasure systems powered by AI can recognize incoming threats like missiles or radar locks in milliseconds and deploy the most effective defensive response without waiting for human input. This not only saves lives but also increases the survivability of highly valuable aircraft in the most dangerous combat zones. The unique selling points of AI in combat aircraft go far beyond performance and safety. One of the most revolutionary aspects is autonomy. In some scenarios, AI will be able to conduct missions entirely without a human on board, either because the mission is too dangerous for human survival or because speed and precision are paramount. Another standout feature is adaptability. AI systems can learn from each flight, constantly refining strategies, optimizing fuel consumption, and adjusting combat tactics based on new intelligence. They can also integrate seamlessly with satellite networks, ground forces, and naval units, creating a fully connected battlefield where every asset supports every other. The price of such technology will initially be astronomical. Research and development for AI-driven combat aircraft involves advanced computing infrastructure, cutting-edge materials science, and extensive testing. Early production units may cost several $100 million each, placing them among the most expensive military assets ever built. However, the long-term operational savings could be significant. AI reduces the need for extensive pilot training hours, can predict maintenance needs to avoid costly breakdowns, and improves fuel efficiency through optimized flight patterns. Furthermore, the ability to deploy aircraft without human pilots can reduce logistical costs and risks associated with rescue operations in hostile territory. In operational terms, the deployment of AI in future combat aircraft means that the very nature of warfare will change. Battles that once took hours or days to plan can be executed in minutes, with AI running simulations of enemy responses and preemptively adapting strategies. The speed of decision-making will outpace traditional command structures, requiring military doctrine to evolve alongside technology. For smaller nations, acquiring AI-powered jets could offer a way to compete against larger air forces, while for superpowers, these aircraft will be essential to maintaining air superiority. Critics often raise concerns about the reliance on AI in life-or-death situations. There is an ongoing debate over the ethical implications of allowing machines to make lethal decisions. Military developers are addressing these issues by incorporating human oversight into AI systems, ensuring that while the aircraft may operate autonomously in many respects, certain critical actions require human authorization. This balance between autonomy and control will remain a defining issue in the coming years as the technology matures. As AI capabilities continue to expand, the integration of quantum computing, advanced sensor fusion, and swarm intelligence will push the limits of what combat aircraft can achieve. Future jets may be able to coordinate with hundreds of autonomous drones, conduct real-time cyber warfare against enemy systems, and use predictive algorithms to anticipate entire campaigns rather than individual battles. The line between science fiction and reality is rapidly disappearing. Ultimately, the role of AI in the future of combat aircraft is not just about building faster, stealthier, or more powerful machines. It is about creating an entirely new paradigm for how nations project power and defend their interests. The aircraft of tomorrow will not simply be tools in the hands of pilots, they will be intelligent partners capable of acting with initiative and precision. Those who master this partnership will dominate the skies, while those who fail to adapt may find themselves outmaneuvered before they even realize a battle has begun. The fusion of human ingenuity and artificial intelligence promises to usher in an era of aerial combat unlike anything the world has ever seen, and that future is arriving faster than anyone could have imagined.